Okay, we have been talking about domains, and we kind of hit on ranges in the beginning, but we've mostly been focused on domains and what we can input into a function and still get a real output value. And we've learned so far that if we're doing a function that has an even root where you have a radicand, the radicand for an even root has to be a positive number. So, or zero, a zero or a positive number. So we have to set it greater than or equal to 0. And then if we're doing a fraction, the denominator can't equal 0. So we've used those two facts to help us find the domain. So now we've kind of got, if you look at this function f of x equals 1 over square root of x, you've got a function where it is both a fraction with a variable in the denominator, and that denominator is a radical. So in this case, this number here has to be greater than or equal to 0. But the denominator can't equal 0. So really, we can only say that it has to be greater than 0. So what happens in this case, because you've got multiple things going on, you've got the rational function, and it's the rational function of a square root, so 1 over the square root of x. All right, we know that the x, because it's under the radical sign, has to be greater than or equal to 0. And we know that the square root of x, because it's in the denominator, can't equal 0. So the first one, that's kind of already solved. X it has to be greater than or equal to 0. The second one, we would square both sides, and we would say x can't equal 0 squared, which is 0. So both of these statements have to be true. It has to be greater than or equal to 0, and it can't equal 0. So kind of where's the intersection of that? That would be here. It's got to be greater than 0, but it can't equal 0. So you just take that equal sign out, and you're good. So we still need to write this in interval notation. So interval notation, we're saying that it has to be greater than 0, but it can't include 0. So that would be 0 to infinity, and it can't include either one, so you would use parentheses. All right, so I told you that we would talk about set builder notation, and this is where you write it in inequality form, but then you put an x in front of it. So it's like, in this case, we're saying x is all numbers such that 4 is less than x is less than or equal to 12. And it's basically writing it in inequality notation, but then putting a little x with a bar in front. And it reads that way. X is all the numbers such that 4 is less than x is less than or equal to 12. So basically we're saying that x is all numbers between 4 and 12, including 12. And then we have interval notation. So we've talked about both of those now. So now, and we've also talked about how to find the domain if we have an equation. But now let's talk about a graph. So if we were to give you the graph instead, okay, graph instead, so given the line graph, describe the set of values using interval notation. So identify the intervals to be included in the set by determining where the heavy line overlays the real line. At the left end of each interval, use a bracket with each end value to be included in the set, a solid dot, or for each excluded end value, use an open dot. Same thing for the right end, and then use the union symbol to combine all the intervals into one set. So that sounds a little crazy. This slide is just kind of showing you how we've been graphing earlier, but like this first one, it shows you this doesn't include 5, but it does include 10. So H, we're using H, I guess, here. H is all the numbers between 5 and 10, including 10, so there's that equal sign. And then this would be set builder notation, so repeating it, but with an H bar in front. So H is all numbers such that 5 is less than H is less than or equal to 10, and this would be interval notation. So you can look at all of those at your leisure, and we will move on to the graphs. So basically, this is what's going to happen. So you're still identifying what it is that you can substitute in for X, what inputs can be included, what inputs would be excluded for the domain. So for the domain, what you're going to do is you're going to say, okay, looking at the domain, what is the leftmost X on the graph? And then for the other side of the interval, you're going to say, what is the rightmost X on the graph? And so what I usually do is I look at the graph from left to right. I just look at the x-axis, all right, and I look at where the x's are. And the leftmost x is right here. See this point here at the bottom? That point falls when x is -3. So -3 is the leftmost x. The rightmost x is 2. So what I usually do is I kind of just go and I draw a vertical line on my endpoints, my left and right endpoints. So I can see that the x value for this point, the leftmost point, is -3, and the rightmost point is +2. Now, let me erase this so we can see. We have a closed circle at x equals -3 and an open circle at 2. So closed circle at -3 yields a bracket, open circle at 2 yields a parenthesis. So this is interval notation, and this is just going from left to right. So looking on your graph, go to your farthest left. If it's a point, then what is that x value at that point that is the leftmost point? And then go all the way to your right. If it's a point, what is the x value for the point that is the rightmost point? If it's an arrow, left or right, then it's going to be infinity. If it's a left arrow, that means it's going to keep going on forever. So that means there's no leftmost point. So that means it keeps going to -infinity. Same thing on the right, it keeps going to +infinity. Now, we didn't do range. So range, you're going to go from the top. I'm sorry, I said this wrong. Strike that. Oops. So we're going to go from the lowest y to the highest y. Okay, so in this case, the lowest point is here. And the y at that point looks like -5. The highest point is here. And what is the y value of that point? That highest value of that point is 4. Because we're looking at the y's. Now it's important to see whether they're included or not. So if you look at this one here on the bottom, that has a point, so it does include -5. So we're going to use brackets. And then the topmost point goes through 4. This point where the y is 4, so it does include 4, so we're also going to use brackets for that one. Okay, so I have another one right here. I do not have the numbers written out, but you can clearly count over and you can see, let's say this point here is at -3, 0. So Why don't you pause the video and try to find both the domain and range. Remember, we're going for domain from left x to right x, leftmost x to rightmost x. Range, we're going from the bottommost y to the topmost y. And when you're ready, unpause and we'll go over it. Okay, so domain, leftmost point is here, which looks like it's at, this is the point -3, 0, right? So the leftmost x is -3. And there was an open circle. Oops. Let me try to do this without erasing everything. There was an open circle, so we're going to use parentheses. All right, the rightmost x is right here, which is the point 1, 1, -4. So in this case, the rightmost x is 1. It looks like a point here, so it is included. So we will do a bracket. For the range, oops, keep erasing the graph. So for the range, we're going to go from the bottommost point to the topmost point and get the y values from those. So the bottom of the graph is here. So y at that place is -4. And it includes the -4 because I'm looking at both points. It hits it twice. So both of those pieces of the graph actually hit -4. So we're going to use a bracket for that. Now the highest point on the graph looks like the x-axis, which is where y equals 0. Now the question is, does it include 0? So if you look here at this point, it's an open circle, and that doesn't include 0. But if you look here, that does include 0. So we are going to do a bracket for that one. All right, so domain and range there. All right, let me shrink this a little. You guys try this one. And pause when you're ready. Okay, so for the domain, the leftmost point is here. So that, to get there, 1, 2, 3, 4, 5. And up 1, 2, 3, 4, 5. So -5, 5 is a point. And then, so for the domain, we start at that leftmost point, and that is the point -5, 5. So the x is -5. And we go to our rightmost point, which happens to be an arrow that's pointing to the right. Now, it's also pointing down. I understand that. But remember, for domain, we're looking from left to right. So this is going down, but it's also down and to the right. So it's going to the right in the direction of right. So that would be positive infinity. Now it does include the -5 because I see a point there, and infinity always has a parenthesis. Range, the lowest number is the same as the rightmost number. So the lowest number, the lowest part of the graph, is pointing down. So that's negative infinity. And then the highest point on the graph, that y is +5, and it does include it. So the domain is -5 to infinity, and the range is -infinity to 5. All right, a couple more. Go ahead and pause and try this one, and then unpause when you're ready. Okay, so for this one, for the domain, the leftmost point, there's the rightmost point. So for the domain, the leftmost point is a left arrow, negative infinity. It needs to be parentheses because you can't include negative infinity. And the rightmost point is a point, and we need the x values. The x value here, I believe it's 7, 2, is that point. Yeah. So the x coordinate in this case is 7. So 7, and it does include it, so we will use a bracket. So negative infinity to 7. So when we're going the other way, for the range, we go from bottom to top. So the bottommost point has what y value, and the topmost point has what y value. So for the range, the bottommost point is the 0.72, and that y is 2 inclusive. And then the topmost point happens to be an arrow. And it is pointing to the left, but it's also pointing, for range, we're going from bottom to top, so it's also pointing up. It's pointing left and up, so that means it's going to positive infinity. Even though it's going left, it's still going up. And when we're talking about y's, when you're going up, that's positive infinity. All right, so one more like this. So this one has 2 pieces. So think about this one and see if you can figure out what the domain and the range would be. Okay, so hopefully you have paused the video and you kind of try to figure this out. So it looks like you've got a graph on the left side that looks like this. It looks like it goes, it's starting from the left and goes up. On the left, if you were going to the left, it looks like it's getting closer and closer to the x-axis, but it's never going to cross the x-axis. Same thing with this line. It's coming up from the left and going to the right, and it's getting closer and closer to the x-axis, but I don't think it's ever going to cross it. On the right-hand side of this graph, this one's getting really close to this line here, this dotted line. Same with this one when it's going down. It's getting really close to this line. This line is called an asymptote, and we will talk more about those later in later chapters and sections. But and I mentioned these when we talked about the graph of a rational function. In an earlier video, we talked about the parent functions, and this is similar to this is a rational function that I've graphed here. So here's the thing. It looks to me like the number, the x that's here, is excluded. So this number is x equals -2. So it looks like that number is excluded from the domain. So in this case, it's all numbers. It's all the domain. It's all reals except -2. Now, how would we write this? So we're going from left to right. We're going from negative infinity to 2, and we're not including, I'm sorry, -2, and we're not including the -2 because it can't equal 2. And then we are picking up from that 2, and our graph is going to keep going to infinity. The x values are anyway. So in that case, it goes from 2 to infinity. Again, doesn't include 2, -2 rather, sorry. Keep saying 2, and I shouldn't say that. I should say -2. And so since it's on 2 different intervals, we will union them with the union symbol. So it's all the x's from infinity, negative infinity, right up until right before it gets to -2 will yield a y. And all numbers right after 2 all the way to infinity will also yield a y. The only number that will not yield a y is -2, so it's the only one not included. So it's all real numbers except for -2, and I've written it as interval notation. Now, the range is very similar, except we're going from lower to upper. So looks like we have all the numbers from here to right when you get to the x-axis. And then we pick back up at the x-axis and go up. So it looks like the only place where there's not a y value is at the x-axis where x equals 0. So basically, is all real numbers. The range is all real numbers except y equals 0. So in this case, y is all numbers from negative infinity to 0 and from 0 to infinity. And the reason I have to write it both times like that, even though it looks like where one leaves off, where the next one picks up, but remember 0 is not included. So you would write it like that. All right, so just to finish up, if we look at each of these, you can go through these parent functions, and you can see the domain and range of each. So for a constant function, the domain is from negative infinity to positive infinity, and the range is just one number, whatever the y is at that point. So they said from C to C. But let's say C equals 3, so the range would just be 3. And you don't have to write 3, 3, you can just write the number 3. So for this one, the domain, we're going from, the x's go from negative infinity to positive infinity. And the range goes from negative infinity to positive infinity. So the leftmost to the rightmost. And then the bottom to the top. Either way, they're both negative infinity to positive infinity. Oops. For both of those. So that's for linear functions. For the in this case, the identity function. So for the absolute value, the leftmost point is negative infinity. The rightmost point is positive infinity. So that's the domain. For the range, the bottommost point is 0. The topmost point is infinity. So there's the domain and range of that one. So similarly, the domain is negative infinity to positive infinity for a quadratic. The lowest point is a 0, so 0 to infinity would be the range. And these are your basic parent functions, the basic toolbox functions that we keep talking about. So in this case, the domain and range would be the same as it was for absolute value. In both cases, 0 is included, so you use brackets. It looks like domain and range are both going to be all real numbers because it keeps going from left to right are arrows, from bottom to top are arrows, either way you look at it. So negative infinity to positive infinity for both of those. For this one, this is very similar to the rational function that we saw up here. Okay, it looks similar. So if you look at the left side, the x's go from negative infinity and then to 0. And except it doesn't include 0. It gets really close to 0 but never crosses it. And then it picks back up just right after 0 and goes on to infinity. So this is going to be one of those where it's a union of two pieces. Same thing for the bottom to top. We do go from negative infinity to 0 and then from 0 to positive infinity. And see, they have the little union symbol in between. Notice parentheses on the zeros because it doesn't include 0 in either case. This is the rational squared. So domain would go from negative infinity to 0, from 0 to infinity, and then the domain would go from 0 to infinity. 0 would not be included in either case. And square root function, 0 to infinity, from left to right, 0 to infinity for the domain, from bottom to top, 0 to infinity for the range. So the domain and range would be the same for this one. And I think the next one is a cubic function, a cube function. So it looks like the domain and range, we've got arrows, left to right arrows, so that'd be negative infinity to positive infinity. Then for the range, we got bottom to top arrows, also negative infinity to positive infinity. There we go. Alright, so we're going to stop the video here, and if you have questions, please let me know.